Okay, I will begin my presentation class. This is the continuation of previous one. So we were talking about software quality in the last class. This is where we stopped. And in fact, we were going through the quality from end users perspective, developers perspective, business community perspective. And I request all the students, please look into that. Every term that you get in the textbook, you would explore more and get into the practices level, right? If you limit yourself to only the textbook, understanding will be very low, right? I request all the people to mute their mic. Right, this is where we are stopped. Now, uh, please look into that. Another interesting thing that what we were doing, you all people have an access, Google Class. In a Google Class, we have some section called in-class question bank, right? And I'm requesting Ashish and his counterpart, right, class representative from girls side to update all these things. I've given access to both of them, right? Now let's have a look into that. What all the updates have been done in this in-class question bank. This will help you to visualize when you read one particular paragraph, how exactly, right, you can visualize the questions and all. Now quickly I'll read these questions, whatever he has added. Okay. Explain with example essential attributes of a good software. With a direct question from book, right? Study and work on polymorphic calls. Direct question. Now look at that. This is one interesting thing that which we have gone through, right? Prepare a business scenario and explain how polymorphic call enables maintainability of the code. See, we have seen okay maintainability in textbook written, right? Black and white, everything is textbook, right? Then how exactly I can achieve it? If I cannot correlate the practices things, doesn't make a sense. So yesterday we have seen this polymorphic call, how it enables maintainability, and you can see my video also where explanation has been given, right? Wait 1 minute. Okay, right. Then one more thing we have added. What is the usability? It is a user experience. How user feel about that, we already explained in the previous class. Then here is one example, and you've been asked to go through the GUI from usability perspective and redesign if required. Justify your redesign. So now you have to go through that. There is no single answer. This also we have explained about that, and we asked them you to work on that. Now list and explain with example various quality parameters from the following perspectives: end users view, business community view, developers view. Right? Thus, and this is where we are stopped again in the last class. So we were talking about okay different perspectives, and yesterday we talked about the rollback schedule. And one more questions I have added in Google class. Look at that. Assume that you are develop. You assume that you have developed. It is not are. Assume that you have right, developed a mobile application and deployed on several client mobiles. As a software engineer, propose a rollback strategy of your mobile application product. This is how theoretical things and where practices you need to put into that. Now, another generic things to more generic things I've added. What is testability? Testability is an ability of the code that you have written, which enables whenever required, okay, testing will make it very easy. That's what is a testability. Now, a generic question is explain with C program how do you write testable code? How do you write a testable code? How different it can be done in object oriented programming language and paradigm. So, we are talking about the testability. I will explain now about this. Study the various organizations that proposes a quality attributes of a software product. List and explain how these are realized in a programming language known to you and programming paradigm best known to you. Okay, question number 19, 20, they're all related. So let me get into the aspect of testability, right? This is the one where, okay, we can look into, right? Testability. Let me use marker pen for this, right? I'm talking about this testability. So how it is being done in a C program? What do you mean by testability? Testability is the way that you write a code so that if any problem occurs, I can easily find out, right, how, where exactly likely possibility of an error or the fault and all. This is what we call testability. It is a programming paradigm. You have a process oriented model like a C programming language, object oriented models paradigm. You have a C++, you have Java. How do you write it? Right? You can see the term testability probably in your black and white. Okay, maintainability, dependability, efficiency, usability. You will see that, and there are many other dimensions. Testability. So I'll give an example. This is an ability of the code which facilitate, okay, the reviewer to locate the fault easily. Right. Now let me take about the basic primitive process oriented model, okay, C language. So best example for making, okay, things known to you is, okay, using printf statements, right? So at a regular interval, you put a printf statement in your code so that intermediate values can be displayed, right? When you are installing product, you will get it on the screen. There are 5 steps. Step number 1 is completed, step number 2 is completed, step number 3 is completed, like this. So whenever, okay, your installation procedure is stuck at some point, you understand that what all the stages it has completed, what other stages are yet to complete. Based on that, is it not that you can easily locate, okay, where exactly it might have gone wrong? So the internal activities, if we can make it known in a very professional way without disturbing much about the end user, right? Small screen, what is happening internally, okay, black and white, if you can display that rolling from bottom to top and all, right? People can scroll it and try to know what all it is doing inside. It is nothing but a heartbeat of a product. Can you make your heartbeat visible to, okay, end user? It means that product, whatever it is doing, make known to in small window which is used for debugging purpose in case of there is any failure of the product. And at the same time, okay, probably you might have understood, for every product you find the log file. Log file is something like a black box in aircraft. It records everything. So whatever you display on the screen, right, what you do is, if it is creating a problem, you can keep on writing regularly in the one file, one text file, regular write. I've done this, I've read this value of, see, for example, a quadratic equation. You can say your log file looks like this, printf in log file. Okay, program started, about to read the value of ABC, value of A is being read, value of B is being read, right? Okay, like this, everything you write, it is called heartbeat. And in case a program is stuck, okay, the file, okay, half written file is ready. Now you will come to know that when you look at the log file, value of A is being read, value of B is being read, right? Value of C is not being read. So there is a problem. Up to B reading, a product has worked, and a value of reading C failed. So you can go there and find out why it is not happening there. What might be the reason? So this kind of log file creation or message writing on the screen using a well-known printf statement enables you to locate easily where might be the fault. This way of writing the code is a good practice, and it enables end user or the, okay, the debuggers, right, to possibly locate. So when such problem is there, you can ask customer sitting here, tell me what all things you got on the screen. They will say client will say that, sir, value reading a value of A, it is done on the screen. Value of B is being read. Afterwards, no, okay, nothing or displayed on the screen. Okay, then with that, you can find out where might be the problems in the product and release a patch and all. So this is how you make the testing of the code in case of the fault, okay, easily you can locate it. Okay, enabling locating the possible areas for the possible faults and all is called testability, right? That is the integral part of the code. That is called programming style, programming practices and all, making the code testable. This is about the process oriented model. Now what about the object oriented model? See, object oriented model, you have services, you have got methods, you got the functions, you write it. Let me write it on the screen and tell you. See, you create a class. So you have this model, known to you. We will tell every class, we will see it in more detail in the another chapter, right? You create a class name, object oriented class. Student is a class. In your fourth semester Java programming, you might have gone through some class you might have created. This is the name of the class. This is the area where all variables you write it, instance variable, class variable, whatever it is there. And these are the method. For example, in case of an account class, right, you write debit. This is the one method. Then you have a credit. This is another method. You write it. Now what you do is, right, you you can add one more method called service, right? Now, what happens is, whenever there is a problem, you can call this and try to know the internal state of a given object. Internal state of a given object is nothing but the value of the instance variable, value of the class variable, whatever you have. Alternatively, this you can make it as a private method and it continuously keep on writing in a log file that whatever I said it in C programming language. It can open a file, keep on writing. Object 1 value changed. Object 1 variable 1 value changed. Object 2, okay, it is reading that. Object it is computing that. Object 3, it is okay gone out of the scope. It is being killed. Constructor and destructors. Right? What all the object is doing, all that activity you can write it in log file, and thereby you can understand the internal heartbeats. Heartbeats are internal only. Internal computation, internal activity of an object, internal activity of a given program in C language, internal activity of what function is doing, which function is called, which function is computing, which function is returning, what not, what not, right? This. So this is a testability. You know about the performance, right? Yesterday we explained about the usability. Today we explained about the testability. We explained okay, yesterday about the rollback schedule, project lifetime we explained, cost we explained, time to market we explained, right? Other things, right? We will explain as and when we come across that. There is something called reusability, right? There is something, I'll take a separate session for this, right? Separate session, very important. There is a activity, programming activity you have to do. Reusability, how do I make my code reusable, right? All the things I will explain to you, okay, separately. For that I'll be calling you an extra class. You should not miss it. If you want to become a good engineer, good tester, right, how testing is to be done, okay, you must attend this. We will take stack as an example, which you are done in data structure, and we will tell you how to write a reusable code. Right? I will explain live, no recorded things. Okay, this particular coming Sunday, I'll be keeping a class for 2 hours at 10 o'clock for you people. You must attend. This all, when I call extra slot, okay, don't feel bad about that because I'm giving an extra stuff to you. Otherwise, simply I can explain what this is reusability and keep moving, which I don't want to do. So now we'll stop here in the sense about the quality attributes. Other things, as and when I come across, I'll explain to you. Right? Even we explained about the targeted market. Right? Targeted market, whom do you target this particular product? Right? That will have a direct impact on your product, pricing, okay, profit margin. The more number of, for example, Microsoft Word, more number of people they use. Catchment area is very, very large. So you can have a okay, smaller margin, lesser price and all these things and sell it. And you are focusing on scientific community, right? Very rarely people being used. They are very costly. It is being used by DRDO, defense. For them, you're developing product. They're all very costly because number of customers are few in number. You can count in the hand. Yesterday, I explained about the maintainability also in length. Except you okay, reusability, portability, right? We will see about the availability very soon. Very soon we will see it, right? So for this, I'll keep moving to next one. I gave an example of one standard, quality standard. You please search and write. I mean, in class question bank, I've added this. What are the okay? standard bodies or something which will propose the quality attributes, right? So this is one. You please search some other thing that keep your knowledge updated. I'll go to the next one.
Excuse me, sir.
Please.
Excuse me.
Okay.
Good evening, sir.
Please go ahead with the question.
Sir, in C programming, as a tester, I'll be keeping the log file, right, sir?
Yeah, not as a tester,
Then what is
not
uh,
as a tester, no, as an architect, as a programmer, as a
okay, sir?
designer.
So then what is the necessary to communicate with the client?
No,
Because
no,
we will be keeping that log. No, sir?
no. What happens is that, okay, that log entries, if a client says that one, my product is stuck at this point, then what I'll say that one, here is a log file is there, take a snapshot of that one, send it to me. Log Client doesn't understand the log file contents because there are a lot of complex internal things also you'll be adding it, right? That is helping you some help for, there may be multiple log file. Some may be useful for the customer, client, some may be useful for the designers. If any problem is there, you can say that one, today's log file, snapshot, you take it, send it to me. They'll send it. Then you will understand where it might have gone wrong because you have designed it. You know the internal architecture. You know the internal heartbeats. You know how the blood is flowing inside. I mean, okay, coding, you have done it. And that is the beauty of, okay, making the code or product testable. Did I answer your question?
Thank you, sir.
Yeah, please understand that. I wanted everyone, whatever the question that comes in the mind, shoot at me, throw at me. You'll get the best of the best kind of things to you people. I'll assure you. Right? Yesterday I gave an example of maintainability example. Right? Testability I gave here now. Reusability in full and next Sunday, 2 hours we'll be doing it. With okay, marking on the screen, I developed something how reusable code can be written for the stack which already are developed in your third semester data structure. I'll do that. Right? Now I'll move to the next question. Are there any question? Ashish, are there any question? If at all you have any question, please put it in the chat box and immediately Ashish will be interrupting me and asking a question to me. Asking more question like this, what okay has been asked, that will enable you to understand better. Please understand this. If you don't ask question, you don't understand anything. Feel free. You can ask any question. Shall I go to next one, Ashish?
Yes, sir, yes, sir. There are no questions here.
Yeah. Thank you. Right. The moment you get any question, you can shoot at me. Right. That's the one thing. And when a session ends, automatically class terminates. Okay. Now look at that another beautiful thing I'm talking about that. People talk about the elegant code. Right. Don't look at the dictionary. Elegant code is a one. It speaks about approach of finding a solution. Remember. Okay. It is a label that you give for the optimum solution, the best solution, performance. Right? And doing better things with the least possible resources. Simple code which people can understand. Right? There is a term, okay, please don't misunderstand me, but I'll be using this term. Okay, this is what is being referred, okay, in software engineering. Right? Please don't misunderstand us. This speaks about keep it simple and not stupid. Keep it simple and not stupid. You have to make your code very simple, readable code. What is a readable code? How does it look? I'll be taking one case study and explain to you on the Sunday. Less new code. The more and more you make the reuse things and all, we appreciate you. Even in a project also. Right? That is what is an elegant code. Right? Anyhow, we will come back to this later. Now look at that. When you look at the system, please, this whenever I show you a black and white, is from your book, right? So when you look at that, this is the hierarchy of an abstraction. The higher level abstraction is a whole system. Can you visualize the whole system in the form of an architecture? We'll see that. Then this architecture is broken into several subsystems. Several subsystems. Each subsystem is broken into several components basket. Every basket contains finally, okay, items inside the basket. So we call these as the object or items or the elements. Then we, okay, these are the called elements, or you can call it as an objects, or this, you can call it as an items. Then this is what we call as a components. Components are made up of the collection of different objects that makes component. Several components together we call as a subsystem. Several systems together we call as a system. This is how you should be in the position to visualize the whole product. That's what in my first class I shown you that video about the, okay, Honda vehicle. That vehicle, you see the abstraction, higher level abstraction. It has a braking system, it has a gear system, okay, wheels and all, okay, engine, lot of things, right? A lot of things. So that's what is a hierarchy of the system. You should be in the position to explain about that. The same thing when I try to show you in the form of an object oriented kind of things. Okay, these are all different object. You should be able to, okay, decompose the whole system into this one object, this another object, this another object, and put together. They're all highly cohesive. They're all connected with each other. Okay, they cooperate with each other. They synchronize with each other. They communicate with each other, right? But you find that one, they together work in an orderly manner, so that the end user is getting services. The end user is getting services here. Microsoft Word, NS2, Oracle database, right? Any network tool that you use, operating system, right? Okay, this is how the decomposition, in simple language, in C programming language, you might have seen that several functions you write it. That is a miniature version of a modular approach. The same thing when you extend it at object level, component level, subsystem level, then this is how it looks into that. Are you getting this? Right?
Excuse me, sir.
Please.
Sir, there's a question in the chat by Ankit. He wanted to know a bit about log file.
Okay. Okay, I'll tell you a log file, simple thing, right? I don't want to ask this question because this is not the right question to ask. But probably you might have seen people who got admitted into hospital. You might have seen it. When you go there, to their bed, one notebook is attached where nurse will come and record the temperature for every 1 hour. Am I right? Am I right?
Yes, sir, yes.
Right. That is called logbook. Every here and then about the patient you record. Blood pressure is this, right? Temperature is this, right? All the things you recorded. That is a log file. And when the doctor comes, he will see, oh, what is the variation of temperature from morning to evening? No variation. Good. It is nothing but heartbeat. Recording heartbeats. Heartbeat are the thing, but what is happening in your body that will be written in the book. Similarly, a product will open one file, normal ordinary file. It will keep on writing what all it is doing. What all it is doing in a particular format, best known to the designer because designer has designed that particular log file. Keep on writing it. And when any problem is there, right, then open that log file, take the copy of that, send it to the product, okay, vendor or designer. They go through that and try to locate where might have been gone wrong. That's all about the log file. It's simple, ordinary text file where whatever the product is doing is being dumped into that. I'm doing this, I'm doing this. My temperature is recorded here. My blood pressure is recorded here. My sugar level is recorded here. Okay, my signals are being recorded here. That's all. It is input to the doctor. It is something like a black box in aircraft. अगर एयरक्राफ्ट को कुछ हो गया तो, right, they open the black box, they come to know until what point product has worked properly. Then here this particular sensor didn't work, so there is a problem here, or everything is okay and there was no response from the pilot was sleeping. There was no response. Voice recording has stopped here. All sensors were working because log file says, but there is no voice from pilot. Probably there was some health issue for the pilot, maybe heart fail. or maybe some other thing, or they might have gone kept it in autopilot mode and they didn't respond. Why they had not responded? Then they look into audio files. Logbook contains heartbeats of engine, heartbeat of the aircraft, heartbeat of the entire operations of the aircraft. Similarly, the product here. Ashish, I think I've answered. Okay, beyond. Okay, what is required?
Yes, sir, yes.
And whenever you do project, please ensure that it contains a log file. Without a log file, no project will be accepted. Right, I'll keep moving to the next one. Oh, don't read. This is a very bad slide.
Excuse me, sir.
Please, please.
Sir, if that file keeps all the details, then why is it called log file? What is the meaning of LOCK log?
When you have entered into CS department laboratory, there's a one book where people used to sign, check in and check out. Am I right? Person who has asked question,
Yes,
please
sir.
unmute. Who's that? What is your name?
Yes, sir. Shrish, sir.
Ashish. Okay.
Sir, Shrish, sir.
Shrish. Okay. Now look into
No, sir,
that.
it's Trish.
Okay. Right. You have entered. Okay. Your entry. Okay. Signature and all in a one book kept in a department laboratory. No,
Yes, sir.
that is called log file. Suppose
Sir,
if there
isn't
is,
it log file?
yeah, it is a log
LOG
file.
log.
Log.
But actually, Ankit was actually asking about the log file, sir. LOCK log file.
I'm not telling about the log file. He might have misunderstood it. It is not a LOCK log file. It is a LOG log file. All this that what we are talking is about the LOG, not LOCK. Good thing.
Yes, I got it, sir. Yes, I
Yeah.
got it, sir.
LOG log file, which you were entering in the making an entry in the book kept in the laboratory when you entered in the laboratory. When you are exiting, you are also putting your signature. Who all have entered between 8 to 9? Got it? To know that one. Right?
Yes, sir. Yes, sir.
Okay.
Yes.
This is a horrible slide. Right? To tell you, you should not write like such a slide. But don't read it. I'm going to tell you about the program and the software product. Program when you write in first year C, simple, plain, third semester plain. It is a set of instruction. Other than that, there is nothing. But when you call as a product, it has a requirement document, it has a design document, it has a technical manual, it has a user manual, it has a programs, right? It has a test cases, it is a lot of customer interaction and all these things. Okay, it has all that put together we call as a software product. Software product is not a program alone. It contains everything, right? So it is there in the textbook. It is there in the video. This video I'll make it available. You go through that, right? But now look at that. This black and white is from your textbook. Very nicely, like a school children. For he writes it. What is software? All this question, right? Ashish, you can put it in our in-class question bank. What is software? Okay,
Yes.
software is a computer program and associated documentation. So far, whatever I said, it is not only a program. What is software engineering? It is a discipline which deals with all aspect of software production, how requirements are being collected, how design is being done, how programming is being done, how testing is being done, all the things. It is a field, it is its own procedures. Put together is called software engineering. So in this course, we are studying all this aspect. Wait for that. Sometimes we'll be using some term ahead of time, but please digest it. That's how book is also written. What is the difference between software engineering and computer science? Computer science is a discipline which deals with the theory and fundamentals. Okay, software engineering is a practice of developing a product. So you will learn all this through few assignments also. Software engineering, so it is a practice. It is not a theoretical thing. Please wait for that. First chapter is a theoretical. What is the difference between software engineering and system engineering? Software engineering deal with the software product development. System engineering, say for example, Consider automobile. Consider aircraft. It includes hardware, electronic part, mechanical part, components, sensors, and also the program. That put together we call system engineering. Whereas only software aspects we call engineering. What is software process? It is set of activities, right? What kind of an activities? I'll skip it. Okay, little bit. Go ahead and tell you. Probably. Okay, now look at that. We have shown this in the first class. Software process include product engineering process management process. Product engineering includes development process, requirement collection, design. Okay, 1 minute. I'll put it the marking. Right? Here, requirement collection, design, ideation phase, then requirement, then design, then implementation, right? Then what is the cost of that? What resources required? When to start? When to begin? They're all project management activities, right? Then configuration, I told you, right? Then process they themselves will go through the changes. This entire thing we call as this. We will see all these things in detail throughout our session in this, throughout our discourse. I'll come back to that. So that's the software process, set of activities. This is a set of activities. We are talking about that, right? Then we told about software is computer program associated documentation we told. Software engineering we told it is a discipline deals with all aspects of software production. Computer science is a theory and fundamental, whereas software engineering concerned with practicalities of developing product. System engineering deals with all aspects, hardware, software, everything. Whereas software engineering deals with software development process. So there is a nice fundamental things have been given which you will practice it. This alone will not make you an engineer, right? We will see that. Software process model, which we are going to see it, right? A simplified representation of software process. We were talking about right here development process. What are the development process? That will deal. Probably when we reach here, there are different development models we'll see, right? I can develop a product using waterfall model, iterative waterfall model, prototyping, evolutionary model, spiral models. You'll be having a definite question on that. List and explain software lifecycle models. Ashish Nadam will explain in the next class, right? Then what are the advantage, disadvantage of waterfall model? Ashish Nadam. What are the benefits of prototyping? How spiral model is different from waterfall model? All these things we will see it here. Got it? So probably next class or next to next class. But by weekend we will look into all this aspect. Let's come back to this. Software process, which what we were talking all about. What are the cost of a software engineering? Right? Okay, yesterday we were talking about requirements, people involved in that, design, people involved that, then testing, people are involved in that, software is required, you have to hire the space and all, pay the rent for that, electricity, water, other faculty, other employee benefits and all, and per day what is the cost of that, and developing a product, how much time is required. So total days required multiplied by number of people multiplied by their wages, that will be the cost of the software plus your profit margin. But when you look at the overall cost classification, assume that something is costing around $10,000. Out of that, 60% of the cost goes in development cost. 40% goes in testing cost. In this way, it is just a knowledge somebody has created. It is indicative. Don't ask a question that who has measured, how did they measure and all. But what are the development? Development includes ideation phase, requirement activity. Somebody is joining here, I'll admit. Please ensure that you join the class on time, right? Then, okay, I was talking about, right, ideation phase, requirement, design, writing the code. All these things will constitute 60% of the cost of the total product. Then 40% is testing. You need to test the code. You have got the last but one chapter where we deal with testing in totality. Right? There is something called software engineering methods, approaches, we'll see. Right? Where what models, what notations, what rule, what guidelines we'll see in subsequent chapters. You may use computer, there are many software development tools you may use. For user interface, you can use some tool which will help you to develop a user interface. That model you can take it and take the code developed there and put into the actual code. Versioning, you can use it. And yesterday you have discussed what are the good attributes of a software. People said maintainability. We gave an example. How polymorphic call enables maintainability of the code. How object-oriented model enables maintainability of the code. Got it? Dependable, reusable. Yesterday we have seen it. One example also we are given and added a question, okay, in our in-class question bank. What are the key challenges facing software engineering? Right? The one of the important thing which already we have told, right? Please look into that complexity of a problem. I think probably where exactly we are written. Did we write it here? Did we know? I think in object-oriented model. Right? We already discussed about that in our first class. Complexity of a project result into software prices. Right? So we go for object-oriented model. So coping with what is being said, this complexity, the term he uses that coping with increasing diversity, demands for reduced delivery times. I wanted tomorrow only, you have to submit all assignments. Reduced delivery time puts you a pressure, challenge, right? And developing, okay, reliable code. Reliable code is a trustworthy code. Assume that you are developing, okay, you are prepared in your kitchen room Jira rice today evening dinner. If I'm a customer, when I come to your home, when you serve to me, I'll say that one first you eat 1 tablespoon of Jira rice. When you eat without any hesitation, I get, okay, the confidence that this is everything is all right. Hope you understand what I'm saying. Got it? Then from the same plate, I will start eating that with a different spoon. Huh? I'll not allow you to mix up the spoon in that. That's a wrong practices, right? So, is it reliable? Is it secure? Is it safe? When I use that one, there is a guarantee that one my money will be transferred to my account only from one account to other account. I like transfer 1 lakh amount instead of going to my another account, it goes to Ashish account, and Ashish will be very happy about that. That kind of payphone or whatever they use, it is not a trustworthy if it happens that. So for that you need a testing. You need to test it thoroughly. But the discipline of testing we will explain in length through practices. Don't worry about that. It's the introductory chapter. That's what I'm saying. That one, don't worry, we'll do. Don't worry, we'll do. Don't worry, really. I'll call you on every Sunday and I'll ensure that you people will work on that. Okay, I'll skip this. Right? When object-oriented chapter will open, we'll look into that. Already in one of your session, I've added to this. What are the benefits of object-oriented things? Why? We have reusability because of the inheritance and composite object. Increased productivity because of the abstraction, which reduces complexity. Ease of maintenance because of the low coupling and high cohesion. Better design understandability because of the low coupling among the objects. I already explained in object-oriented session, which was conducted by, okay, uh, uh, Rangnath. Ashish, am I right? Rangnath has conducted, okay, for you people. Ashish,
Yes,
Rangnath,
sir.
Rangnath
Sir, I
has
disconnected. I don't know where exactly exactly. I got disconnected.
Okay, right. It's okay, all right. Okay, we will look into it. That object-oriented programming, introductory things, first 2 hours I've taken a class there where I've done all these things. Right? Okay, that video I'll add it here also if required. Otherwise, anyhow, we have got a second or third chapter, we'll discuss about this. Uh, Symptoms of software development problems. What are the problems you people face? Business needs are not met, requirement churn, requirements not understood properly, ambiguous in nature, frequently changes, lot of headache. Module don't integrate. When you develop a module, it doesn't integrate properly when you do integration. Right? When two functions you write, two functions do not coordinate with each other properly. Mismatch. Hard to maintain. Maintainability problems. When a flaw occurs, it becomes very difficult to locate where things are there. Whenever you want to do changes, okay, you find it difficult because it's not well organized baskets. Late discovery of flaws, poor requirement collection, poor design, poor quality or end user experience, usability. I put a question on railway reservation user interface. Poor performance, it takes a lot of time, it takes a lot of memory. No coordinated team effort. If you do not coordinate with each other, then you find a horrible product. Build and release issues. When you release a product to the things, you have a lot of problems. Today you are assured that you are going to release that one, it doesn't get released. I'll skip simply all these things. Okay, we will see that one, all these things. Right, part of the video, you can have a self-learning exercise. Right, as and when required, I will call this back. You can refer my video, this video, which is available. This also you can refer it. Right, I'll not take up right now. This also I will not take up, but I will revisit on this later. This is called rational unified process. We'll come back to this. So what is the software process? Black and white from your textbook. I told you it is a set of activities. What kind of an activities? Activity which contains, right, collecting requirements, developing, designing, programming, testing, right? And a product undergoes revision. Product undergoes revision. It's called evolution. It gets modified. New change requirement. Adaptive maintenance, I told you, right? Adaptive maintenance, corrective maintenance. Already we have referred to all these things. All these things are included. Then we have a software process model. Next 5 minutes, it is going to terminate. When it terminates, class ends. Now look into that. There is something called workflow model, data flow model, role and action model. Again, you have to note down, Ashish, list and explain different software process model. Software process model is nothing but, okay, various process that is being used. Workflow, right? One stage to the other stage, one process to the other process, how the work is being transformed. We will see it. Data flow, from one stage to other stage, how data is getting transformed. We'll see it. Role and action model, right? There are different roles, head of the department, faculty members, okay, student and all. How to the role and how do they trigger what input they get it. The people involved in that, it projects it. We will see all these things, okay, as and when things comes up, right? In coverage as per the textbook. Already discussed about the software process model, right? List and explain software development process model. This is generic, then specific, we get into all these things. Classical waterfall model, iterative waterfall model, prototype model, evolutionary model, and spiral model in the next class. In the next class, when we begin, if at all you have any questions, you can ask. You need not wait till the end of my session. Any question so far? Ashish? If Ashish is not there, somebody can take over.
No,
Ashish,
no, sir. No,
there are no questions?
no,
If
sir.
you,
Only one was there that I asked you.
okay, if you have any questions, even in next class also you can ask it. This video I'll make it available by late night
Yes.
today, maybe around by 10 o'clock. This video will be available in our Google class. You can play and see it for any revision that you want to do, right? With this we come to the end of this particular session, right? Thank you, right, all of you, right? So I will,
Thank you, sir.
okay, I will stop this particular thing. I'll stop 1 minute. I'll stop sharing the things. As many as 54, 60 people have joined. Now it has become 54. Maybe due to network problem, they can see my videos and all. Right? I wanted everyone to attend the class. Don't miss it. It will help you for your project as well as getting knowledge, right? And placement also. Thank you. For this, I will end the meeting. You can all exit. Okay, tomorrow is as per timetable. See that one when is my class. Accordingly, we'll do it. Thank you. Bye, Ashish and everyone. Right? Bye.
Yes.
Bye.
Yes, sir. Thank you.
Bye.